Article 250.80 of the 96 NEC requires that metallic water piping within a building must be bonded to the grounding system at only one point. Exception 1 allows this bond to be made to the cold water pipe at any point within the building's interior. An interpretation suggesting that bonding the incoming water supply to the building steel negates the need for this additional bonding is incorrect. Exception 1 does not provide an exception for bonding the incoming water supply to the building steel in lieu of the required water pipe bonding. The purpose of bonding the metallic water piping within the building to the grounding system is to ensure that all metallic components of the water piping system maintain the same electrical potential. This equalization of potential prevents the flow of electrical current between the water piping system and other building components, which could lead to damage or injury. In a situation where the incoming water supply is bonded to the building steel, that bond helps to ensure that the building steel is at the same electrical potential as the water piping system. However, it does not provide the necessary bonding between the metallic water piping within the building and the grounding system, as specifically required by the code. Therefore, it is important to understand that the metallic water piping within the building must still be bonded to the grounding system at one point only, regardless of any bonding to the building's steel at the incoming water supply. This bond can be made at any point within the interior of the building, including at the incoming water supply itself, but it must be present. Consider a scenario involving a fault in the electrical system. If the metallic water piping is not properly bonded to the grounding system, a fault current could flow through the piping, potentially energizing it. Anyone coming into contact with the energized piping could receive an electrical shock. The bonding connection provides a low impedance path for fault current to return to the source, tripping the overcurrent protective device such as a circuit breaker or fuse, and clearing the fault. Building steel is often used as part of the building's grounding electrode system. However, it is not a substitute for the specific bonding requirements for metallic water piping. The building steel provides a general ground reference, while the water pipe bonding ensures that the water piping system is of the same potential as the grounding system. The code emphasizes the importance of bonding metallic water piping because water pipes can run throughout the building, potentially coming into contact with various electrical systems and equipment. Without proper bonding, the water pipes could become a source of electrical hazards. To ensure compliance with Article 250.80, it is essential to verify that the metallic water piping within the building is bonded to the grounding system at one point. This bonding connection should be made using a listed bonding clamp or other approved method. The size of the bonding conductor should be determined based on the size of the service entrance conductors, as specified in the applicable tables in the NEC. Furthermore, it is important to inspect the bonding connection periodically to ensure that it is in good condition and properly connected. Corrosion or loose connections can compromise the effectiveness of the bonding, increasing the risk of electrical hazards. If any issues are identified, they should be addressed promptly to maintain the integrity of the grounding and bonding system. Now let's delve deeper into the specific requirements of Article 250.80. The article states that the bonding connection must be made to the grounding system at one point only. This is to prevent circulating current in the water piping system, which can cause corrosion and other problems. The exception to this rule allows the bond to be made to the cold water pipe at any point within the interior of the building. This provides flexibility in locating the bonding connection, making it easier to comply with the code. The bonding conductor must be sized in accordance with Table 250.66 of the NEC. This table specifies the minimum size of the bonding conductor based on the size of the service entrance conductors. For example, if the service entrance conductors are 4/0 American wire gauge copper, the bonding conductor must be at least a number 2 American wire gauge copper. The bonding conductor must be connected to the water pipe using a listed bonding clamp or other approved method. The clamp must be suitable for the size of the water pipe and the bonding conductor. It is also important to ensure that the clamp is properly tightened to provide a good electrical connection. In addition to bonding the water pipe to the grounding system, it is also important to bond any other metallic piping systems within the building, such as gas piping and heating ducts. These piping systems can also become energized if they are not properly bonded. The bonding requirements for these piping systems are similar to those for water piping. They must be bonded to the grounding system at one point only, and the bonding conductor must be sized in accordance with Table 250.66. It is also important to ensure that all metallic equipment within the building is properly grounded. This includes electrical panels, motors, and other appliances. Grounding helps to protect against electrical shock by providing a low impedance path for fault current to return to the source. The grounding requirements for electrical equipment are specified in Article 250 of the NEC. Now, let's discuss some common mistakes that are made when bonding water piping systems. One common mistake is to bond the water pipe to the grounding electrode conductor instead of the grounding system. The grounding electrode conductor is the conductor that connects the grounding electrode to the grounding system. It is not intended to be used for bonding equipment or piping systems. Another common mistake is to use an undersized bonding conductor. The bonding conductor must be sized in accordance with Table 250.66 of the NEC. Using an undersized conductor can compromise the effectiveness of the bonding, increasing the risk of electrical hazards. Another mistake is to fail to properly tighten the bonding clamp. The clamp must be properly tightened to provide a good electrical connection. A loose connection can increase the impedance of the bonding path, reducing its effectiveness. Now let's talk about the importance of periodic inspections. The grounding and bonding system should be inspected periodically to ensure that it is in good condition and properly connected. The inspection should include checking the bonding connections for corrosion or looseness. Any issues that are identified should be addressed promptly to maintain the integrity of the grounding and bonding system. In conclusion, Article 250.80 of the NEC requires that metallic water piping within a building be bonded to the grounding system at one point only. This bonding helps to prevent electrical shock by providing a low impedance path for fault current to return to the source. It is important to understand the specific requirements of this article and to ensure that the bonding is properly installed and maintained. Failure to comply with these requirements can increase the risk of electrical hazards. Remember, bonding to the building steel at the incoming water supply does not negate the need for bonding the metallic water piping within the building to the grounding system as required by Article 250.80. It's crucial to maintain a comprehensive understanding of the NEC and its requirements to ensure electrical safety and compliance. This includes staying updated on any revisions or amendments to the code. Consulting with a qualified electrician or electrical engineer can provide valuable assistance in interpreting and applying the code to specific situations. They can assess the existing electrical system, identify any potential hazards, and recommend appropriate solutions to ensure compliance and safety. Staying informed about electrical safety practices and regulations is essential for anyone involved in the design, installation, or maintenance of electrical systems. By understanding the principles behind the code requirements and adhering to best practices, it is possible to create a safe and reliable electrical environment. The NEC is a complex document, and it is important to consult the specific edition adopted by the local jurisdiction. The requirements of the code can vary depending on the location and the type of installation. Therefore, it is essential to stay informed about the local codes and regulations and to comply with them. Electrical safety is a shared responsibility. By working together, electricians, engineers, inspectors, and building owners can create a safe electrical environment for everyone. This includes educating the public about electrical safety hazards and promoting safe practices. The ultimate goal is to prevent electrical accidents and injuries. By following the NEC and implementing best practices, we can reduce the risk of electrical hazards and ensure a safe electrical environment for all. This discussion has focused on the bonding of metallic water piping. However, it is important to remember that the NEC also contains requirements for grounding other types of metallic systems such as gas piping and heating ducts. These systems must also be properly bonded to the grounding system to prevent electrical hazards. The specific requirements for grounding these systems are outlined in the NEC. In addition to the NEC, there may be other applicable codes and standards that must be followed. These may include local building codes, fire codes, and industry standards. It is important to be aware of all applicable codes and standards and to comply with them. The information provided here is intended for educational purposes only and should not be considered a substitute for professional advice. If you have any questions about electrical safety or the NEC, you should consult with a qualified electrician or electrical engineer. They can provide specific guidance based on your individual circumstances. Electrical safety is a serious matter and it is important to take it seriously. By following the NEC and implementing best practices, we can reduce the risk of electrical hazards and ensure a safe electrical environment for all. Remember to always disconnect power before working on any electrical equipment. Use appropriate personal protective equipment, such as gloves and safety glasses. If you are not qualified to work on electrical equipment, call a qualified electrician. Your safety is our priority. Please exercise caution and follow all safety guidelines when working with electricity. Let's continue by exploring more advanced concepts within the NEC regarding grounding and bonding. This deeper dive will help to further clarify some potentially ambiguous aspects, especially concerning different interpretations and field applications. Firstly, it's vital to grasp the concept of impedance in grounding systems. Impedance is the total opposition a circuit presents to alternating current and can influence how effectively a grounding path conducts fault current. A low impedance grounding path is crucial for quickly clearing faults, reducing the duration of potentially dangerous voltage exposure. The NEC emphasizes maintaining this low impedance to facilitate the operation of overcurrent protection devices like circuit breakers. Secondly, consider the role of supplementary grounding electrodes. While a single grounding electrode is often sufficient, supplementary electrodes can significantly reduce ground resistance, particularly in areas with high soil resistivity. These additional electrodes enhance the effectiveness of the grounding system by providing multiple paths for fault current to flow back to the source. The NEC provides guidance in the spacing and installation of supplementary electrodes to maximize their impact. Thirdly, understand the distinction between equipment grounding conductors and bonding jumpers. Equipment grounding conductors provide a path for fault current from non-current carrying metal parts of equipment back to the source. Bonding jumpers, on the other hand, connect different metallic parts together to ensure they are at the same electrical potential. Both are essential for creating an equipotential plane, reducing the risk of electric shock. The NEC specifies the appropriate sizes and types of conductors for both applications. Fourthly, explore the specific requirements for grounding and bonding in different types of occupancies. For example, healthcare facilities have more stringent requirements due to the presence of sensitive medical equipment and the potential for direct patient contact. Similarly, industrial facilities with large motor loads and complex electrical systems require careful consideration of grounding and bonding to prevent equipment damage and ensure personnel safety. The NEC addresses these specific needs with tailored requirements for each type of occupancy. Fifthly, consider the impact of harmonics on grounding systems. Harmonics are distorted waveforms that can cause overheating and other problems in electrical systems. They can also increase the current flowing in the grounding system, potentially overloading it. The NEC recommends using appropriately sized grounding conductors and considering the use of harmonic filters to mitigate the effects of harmonics. Sixthly, understand the importance of proper documentation and labeling of grounding and bonding systems. Accurate records of the grounding system design, installation, and testing are essential for future maintenance and troubleshooting. Labeling grounding conductors and bonding connections helps to ensure that they are properly identified and maintained. The NEC encourages the use of clear and concise labeling to facilitate safe and effective maintenance practices. Seventhly, keep abreast of changes and updates to the NEC. The NEC is revised every 3 years to reflect advancements in technology and address emerging safety concerns. Staying informed about these changes is crucial for ensuring compliance and maintaining a safe electrical environment. Participate in continuing education courses and consult with qualified professionals to stay up to date on the latest requirements. Eighthly, consider the role of surge protective devices, or SPDs, in conjunction with grounding and bonding systems. SPD protect electrical equipment from transient voltage surges caused by lightning, switching operations, and other disturbances. They work by diverting surge current to ground, reducing the voltage stress on sensitive equipment. The effectiveness of SPD depends on a properly designed and installed grounding system. Ninthly, remember to always use listed or certified equipment and materials. Listed equipment has been tested and evaluated by a recognized testing laboratory and found to comply with applicable safety standards. Using listed equipment helps to ensure that it is safe and reliable. The NEC requires the use of listed equipment whenever possible. Tenthly, emphasize the importance of ongoing training and education for electrical workers. The electrical industry is constantly evolving, and it is essential for electrical workers to stay up to date on the latest technologies, techniques, and safety practices. Ongoing training and education can help to improve their skills, knowledge, and safety performance. By continuously improving their knowledge and skills, electrical workers can contribute to a safer and more reliable electrical environment. Remember, the goal of grounding and bonding is to create a safe electrical environment for people and equipment. By following the NEC and implementing best practices, we can minimize the risk of electrical hazards and ensure a reliable electrical system. Always prioritize safety and seek professional assistance when needed. Safe electrical practices are not just a requirement, they are a responsibility we all share.